Hi, welcome back. In this video, we look at how to do clustering using Excel Miner. By now you're familiar with what is clustering. Clustering is grouping of objects or people or products that are similar in characteristics across many different dimensions. So in this particular example, this is a set of 178 wines that are from different geographic regions that are classified under different types. We have three types, A, B, and C, which is on in the column A. These are based on where the wines came from. Each wine was tested for various content, alcohol, malic acid, and so on. There are 13 variables. Now, in this exercise, what we'll do is, can we use these 13 variables and cluster them into three different groups? Eventually, we'll try to match this cluster with the type and see how well they match up. So in order to cluster them, we're going to use Excel Miner. If you click on Excel Miner platform and cluster, you see there are two major types of clustering methods, k-means and hierarchical. In this exercise, we look at k-means clustering, where we exactly know how many clusters you want. In this case, we need 3 clusters. The idea behind this k-means clustering is the objects within the clusters are close to each other, and the clusters are as far as possible. So in this case, every object is very close to each cluster mean, and the means of the different clusters are as far as they can be. So how it is done? Through a mathematical way, which we are not going to go into the details. So let's click k-means clustering. We want to make sure the data range is correct. In this case, it is correct. The first row contains headers. Now, we are not interested in type, but we are using all the other variables. You can individually select, or you can select all the variables and click here. Once you selected the variables, click Next. The key thing here is normalize input data. The question is, why do we want to do that? If you look at alcohol, it's in a different range compared to ash. So when you're trying to group them based on different characteristics, if one number has much larger range, they tend to dominate the ones that have less. For example, if you look at this column, it has in the range of 0.3, 0.2, while these are 13 and 14. So in order to make all the variables equal so you can compare them, we tend to normalize it. So when we normalize means here in case we convert them to what we call a standard normal curve with mean of 0 and the standard deviation of 1. So we click on normalize input data, and the number of clusters is 3. We won't go into the other details about iterations or other methods here. Say Next, and then finish. So the calculations are pretty fast. It has now classified each wine into different clusters. You can see that in the initially you have a lot of 1s and 2s and 1s, and later on we'll have mostly 3. So you put into 3 different clusters. You can go to the clusters and see what are the means. Remember, we converted this into standard normal curve. So if you look at the alcohol mean of cluster 1, 2, and 3 are quite different. Likewise for ash and other variables. So let's go back to this particular cluster ID, and now what we'll do is, let's see how well is this clustering compared to the type that we already know. So we'll highlight this column, copy that, and we will put it right here. So we want to highlight this particular data range, everything. And what we'll do here is create a pivot table. So in order to create a pivot table, insert, pivot table here, select that, and we want to make sure the range is correct. Yes. Into a new worksheet, say OK. Now drag the type and put it in row so it picks up A, B and C. Cluster ID in the column, so you have 1, 2 and 3. Then take the type again and put it in the values, so it will now count the number of rows in each of those combinations. So if you look at this A and 1, so that what we know is A, B, C, and the system has generated 1, 2 and 3. So 59 of the A's have been identified correctly and there has been no error. Likewise for C, there are 48 and there has been no confusion. Of course, when it comes to B, it has identified 62 of them correctly, but there is some errors as well. So this B is misidentified as 1 and there's one that is identified as 3. So in some sense, you have 9 wines that have been not correctly classified, which is equal to about 5.05%. In reality, it's an excellent classification with an error of just about 5%. We can use this information in many different ways. Whenever we have misidentified, there's a penalty for you. So we can compute the penalty. We want to keep the penalty as low as possible. So let's take an example. Assume A is a cheap wine that is about $10. B is slightly expensive, say $25, and C is an expensive one, is about $50. By misidentifying this one particular wine, instead of being C but classified as B, you are giving up some of the margins because you are selling a expensive wine as a cheap wine. On the other hand, you have cheap wine and you classify it as an expensive wine, and customers will be very unhappy after paying more for this. So you want to keep this thing to a minimum, the penalty. So we can use this kinds of analysis to see how good is your clustering. Of course, if you get, now we know that clustering works very well. So once we analyze the content within each wine, we can put all of them together and then cluster them into different groups. So this is how we do clustering using Excel Miner.